I don't need to train the model on that. I can just give it some more information in the prompt itself, basically.
Exactly. But in order to do that at scale, you need to have it really intelligently retract that or retrieve that context as you prompt. Otherwise, you're going to be digging through documents and you don't even know what you don't know. There may
Yeah,
be a
yeah, yeah,
document
yeah.
out there that has the answer, but you forgot to include it.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsipher, Chief Solution Architect, author, and most importantly, your host. On today's episode, large language models, RAG, and Macintosh computers, with returning guest Matthew Pulsipher from Mac Stadium. Matthew, welcome back to the show.
Glad to be back.
Hey, you've talked to us about GenAI. You've talked to us about cybersecurity. And today you just released a white paper and I said, "Hey, we got to promote the white paper on the show." But before we get into the topic today, I know you really well, but my guests don't know you all that well because I don't think you did a big, huge introduction. So I always say to all my guests, "You're a superhero. What are your superpowers and what is your backstory?" Because people want to hear your backstory. I know it really well because you're my oldest son. So I know your backstory. So it'd be interesting to hear your perspective of your backstory compared to what I would have said.
Man, on the spot.
I know. See, I'm good that way.
I would say my superpower is systemic thinking, just being able to know enough of the details about a larger system to be able to understand it from the 20,000-foot view.
That's a really cool superpower. That's one of mine. So I like that one. All right, your backstory. You need every superhero has a backstory.
How literal are you taking this? Um,
Well, you
Not sure on
started
that one.
off as a software engineer, right? You started off
Yeah, so
computer
so
science.
like a literal backstory of your
Yeah,
life.
literal backstory. Yeah.
I mean, I've touched kind of a little bit of every stack of the IT stack. I've worked in help desk, I've done some software development, I ended up being a systems administrator, a little bit of enterprise architecture work, and then I kind of pivoted, did product management for a hardware startup for a while, and wore all the hats from UI design. And now I'm just in product management for cloud infrastructure at Mac Stadium.
So that's a pretty. I mean, you're a generalist.
Definitely.
Definitely. Well, and they're very rare and far between. So that's why you can talk to us today about generative AI and specifically private Gen AI. And I've had quite a few people come on to the show and talk about private Gen AI, but you have an interesting play on this from a full holistic systems point of view. So, how hard is it to set up a private Gen AI? What steps do I need to take? Where do I start, Matthew?
So, I mean, a typical private Gen AI system, you have different components. There are a lot of off-the-shelf apps that make this really easy too, that bundle these components together. But I think in order to have a quality solution, and especially if you want to host it as a server, like share it with a team or something, you need to understand the components. So you've got your model, which is like Llama 3.1 or some of the fine tunes of that, like Nemotron, or you've got Mistral. These are typically open source models that you can download and are the LLM that you're interfacing with. So like that's the model. That's what most people consider the AI. Like ChatGPT 4o is a model. So
Okay,
you've
so I
got
need a
that,
model.
but you also need a server to run it on, like a software server to host the model and intercept requests. So with that, you usually go with the LLM host. The most popular out there is Olama, and it's widely available on any platform, and we'll kind of get to that in a second. So you need a backend that runs the LLM, and then you need a front end for your users to talk to the LLM. So a good example of this is something like Anything LLM, where it's connecting to Olama, providing the web interface. And now with that, you have a very basic private AI solution where users can talk to a AI model and that model, it's not logged anywhere other than the server itself. Like whatever happens in the box or in the solution stays in the solution. It's not being intercepted or trained on by another party. Now,
So no fear of data leakage if I'm running a private Gen AI model. We've talked about this in the past and other episodes. So I just need a model, a server, and a front end application or website that talks to my model that I'm hosting.
in essence, yeah, that's where it starts. And that would give you basic chat functionality. But where you get a lot of the value is harnessing private context. So if I have a Gen AI model, like an LLM, and the host and the front end, I can chat with it, same as ChatGPT. But if I chat with it, I'm going to get generic answers because it's basing it off of the knowledge of the whole world, essentially. When I add something into a prompt, that's the only context it's running off of, and all it can do is extend and respond to the context I give it. So the less context you give it, the
So
more generic the answer.
got it. So also the answer is dated too. There's a temporal aspect to it, right? Because the model was trained on data. So how old is this data that these models have been trained on? Are we talking 2 years old, 5 years old, 2 weeks old?
I would say roughly 6 months. Meta in particular releases very shortly after they complete training, but at the same time, 3.1, it's been several months now.
Okay,
And
so
while
so the
3.2 is out, that's a different kind of model. Like it doesn't solve the same problems that 3.1 has.
gotcha. So it the information becomes stale in these models over time. That's why adding context to it can be valuable.
Right. So the context that you need, especially in a business situation, right? Like every business is different. You use internal lingo, they operate differently. You have different customers and different contexts, and none of that is reflected in the model. Like anything that you've protected from the world that's confidential is by nature not going to be in the model. So its ability to help you if you give it snippets of, oh, hey, I have this one document, like grade it. It's going to grade it as someone off the street would grade it because it doesn't know anything about your business.
Okay, so that makes sense. So providing context around my business or my culture at my company, whatever the case may be, can actually I don't need to train the model on that. I can just give it some more information in the prompt itself, basically.
Exactly. But in order to do that at scale, you need to have it really intelligently retract that or retrieve that context as you prompt. Otherwise, you're going to be digging through documents and you don't even know what you don't know. There may
Yeah,
be a
yeah, yeah,
document
yeah.
out there that has the answer, but you forgot to include it.
How do you
Sorry.
fix that?
That's where context insertion and retrieval-augmented generation, commonly referred to as RAG, come into play. The way that RAG works, there's actually a third model that you need, and that's called the embeddings model. So the way that RAG works is I have my front end and I've got my LLM model. Well, that front end, in this case, with anything LLM, comes with a database called a vector database. And in the vector database, I have sliced up chunks of uploaded documents that the model retrieves when answering questions and inserts as context into the prompt. It does this via an embedding model, which in this case also runs on the same LLM backend that the same backend that the LLM model is running on. So Olama can run both at the same time. So this embeddings model intelligently, when you upload a document, splits the document into chunks and assigns weights to the vectors that are stored in the database. So those vectors correspond to different chunks or segments of text. When you enter a query in, it will run your query through the embedding model and generate vectors from that. And the vector database matches the generated
Whatever
vectors to the
matches.
stored vectors, retrieves the relevant snippets or chunks of text, and inserts it in as additional context so that the model knows what to respond with. And the result is you get much, much better results without having to manually upload full documents into your prompt, which also saves you on context length. So having a tiny snippets helps immensely with being able to maintain a full conversation with that.
So how much influence do you have over the embedding model, because the embedding model is the one that's kind of making the decision on what chunks of data to put into your prompt. So that becomes very important, that embedding model. How much influence do
Absolutely.
I have over that embedding model if, for example, it's not doing everything I want it to do? How can I change that? Are there ways to change that? Or do I try a different model? You know, what does that mean?
You can definitely, there are a couple things you can do. You can change the threshold for matches so that you only retrieve high matching snippets. So ignore anything with the temperature under this when I query the database. You can limit or extend either the size of the snippets or the number of snippets inserted into the document. So those things are going to be very data set dependent. It really depends on what your documents look like. If they're very well sectioned out documents, like documentation for an API or something along those lines, more small snippets might be the better way to go. But if it's like, here's how our organization is structured and our general operating rules, maybe you do need longer segments. Now, the other
So
side,
that tuning of that embedding model is kind of trial and error then, right? You'd say, "Oh, I'm not quite getting what I want, increase my threshold or decrease my threshold, either way, increase my chunking size." Those are all things that you can play around with to get better results.
definitely.
Okay.
And it's all going to be dependent on your data. The other side of it, though, like you'd said earlier, can you switch the model out? So with anything LLM in particular, if you just download the app version, like it's a pre-built all-in-one package that runs the desktop app, it comes with an embedding model, but comes with a very small one. And in my experience, I've had better results replacing that with one of the better models out there, like Mixed Bread, MXBAI large, using a smaller LLM, I get better results with a larger embedding model than I do even with the Llama 3.1 CB and the default embedding model that comes with anything. Because it can be kind of bad if you can't pull relevant results into your prompt because LLMs consider everything in the prompt as context. So if you're not getting a strong
Yeah.
match, you can actually get worse results than without the context.
So that's really interesting. Your embedding model could actually be larger than your prompting model.
Not as much in
Well,
practice.
it could. I mean, it depends on the context, right?
I have seen some approaches that are taking some of the larger LLMs or the smaller LLMs, small large language model, like an
Yeah, yeah.
8B,
Small language
and
model.
repurposing that as an embedding model. And that might be really relevant depending on what you're doing.
Fascinating. Fascinating. Okay, so let's say I set all this up and I add documents to my RAG, right? Retrieval Augmented Generation. How big I mean, can I put terabytes of documents in there? And is it going to take a long time the larger my RAG is? Or should I have multiple RAGs, one for HR and one for my engineering team? And I mean, what's a better way to go? It's a more centralized that understands everything, or segmented based off additional context.
So segmenting, I would definitely say, is essential because, again, the relevance of the snippets dramatically affects the result. By default, with anything LLM, they organize things into workspaces. So you're putting different sections of documents into different workspaces so different users can be given access. Here's the HR one. If you have HR questions, message this. If you have engineering documentation questions, message this, because they're totally separate contexts that they
So
should be
this could be
operating in.
very interesting. Here's a crazy thought, because you're your dad, and I have crazy thoughts, right? What if I just ask a question? It says, "Hey, the question that you asked is an HR question." It automatically then goes to that workspace for me and submits the question. So there's this segmentation that happens dynamically with another LLM. And I think that's how I'm almost positive that's how OpenAI does it. They have
Oh, that's
multiple
how
LLMs.
OpenAI does it. It's how Meta does it in production with their Meta AI product. That's how their
Okay.
safety models work. I mean, their classifier will say, hey, this doesn't look like a very safe prompt. Just reject it. Don't even process it. That saves them a lot of processing power. Or maybe it's tool usage. They're asking for a question, I don't have a clear answer to it, or I can classify this question likely has to do with current events or something that is less likely to be in the context. So go ahead and do a web search before we do anything else.
Now, see, this is really cool because what we're seeing now is large language models are being injected into programming, right? To handle fuzzy requirements, to handle fuzzy user input. And that means I could set some of these up myself in my own private Gen AI. There's no reason why I couldn't. It's not that difficult.
I mean, generally speaking, anything that's on Hugging Face, you can pretty much all run locally in one way or another.
Okay, so is Hugging Face where everything is? Is that the de facto
It's
standard
like
to go
GitHub for
download?
models.
It's GitHub for models. Okay. And is it the only one that's out there or is it just the biggest one?
It's the biggest one.
Okay.
I know with Olama, they do maintain their own front end to repository, but I'm not actually sure if the repo is hosted by Hugging Face or not. But they have their own command line tool. You can just say, I want to run this model with this quantization, and it'll pull it.
Okay.
But it
Now
might be pulling from Hugging Face.
you
I'm not
mentioned a
sure.
new word, quantization.
Yes.
All right. What in the world does that mean? I think I know, but I know that you know. So what's quantization?
So quantization is where you take, and this is a complicated topic. I'm going to try and explain it the best
Yeah, just
to my
simplify
knowledge.
it. Yeah.
So every model out there is made of a certain number of parameters, and these parameters are weights to different words, to different, not even really full words, but just different segments and tokens, right?
Okay.
And so like Llama 3 PB is a 70 billion parameter model. There are 70 billion weights in this model.
In the neural network, right?
Yep. And the weights are all numbers. They are very long numbers. By quantizing them, we're reducing those numbers down to a certain bit length. So 8-bit, they come as 16-bit by
Uh,
default.
so what that means is they're probably floating point numbers first. I quantize them into integers. So I can run them a lot faster.
But you're losing some of the accuracy. And it's an interesting
Okay.
trade-off. Like
So
it's really hard to say because it's such a subjective thing. Like what is the quality of a piece of writing?
I don't know. My high school English teacher sure knew how to do that.
People have tried to, they've built all these evaluations around reasoning and ability to solve problems. But quantization's an interesting one. So I think the general consensus, and it really depends on the model. It all depends on how they train it. How efficient were they with those weights? Earlier models quantized really well because they were inefficient. With Llama 3, quantization 3 and up has a much heavier impact. On the other hand, generally speaking, it's accepted that a larger parameter model with more quantization outperforms a smaller parameter model with less quantization.
So that's really interesting because I can let's say I quantize to 4 bits.
And
That's
that's
a
what
lot.
Olama does by default, because most people are running on these dinky little GPUs. For consumers, they only have 16 gigs of RAM. We'll get to that.
So yeah, so that's interesting. What it means is I don't need as much memory and I don't necessarily need a GPU anymore because I can do integer math in CPUs pretty fast, especially with multi-threading and with AMX and you know some of the vector processing coprocessors that are out there. So to do inference on these large language models, which means actually use the model, not train them, I can get away with some quantized models, it sounds like, at higher parameters than a full floating point, smaller long model that's going to take more memory. This is really fascinating. There's a lot of moving levers with this.
Definitely. And I mean, quantization can be the bridge that from like not going to work to going to work. Like GPUs and neural engines are always going to be superior to CPUs when it comes to processing these
Well, because
models.
because
They're built
they're
for it. But at the same time, if I can take What if I quantized a small model down even more? Now I'm embedding models in apps and I'm not tanking the entire system performance to do it.
Ooh, see, that's really interesting too, because you talked about embedding the model directly in an application. I can also possibly embed it into silicon, right? Which means instead of taking 1,000 watts of power for a GPU, I can get into sub-watt or 2 or 3 watt um, large language models sitting on a chip that now I can put anywhere. That that to me is really fascinating.
To be honest, it's in its infancy, but this is kind of what Apple did with Apple Intelligence. It's a very heavily quantized 2B model that has very specific guidelines on what it can be used for. It's not a chat model, but it can summarize text, it can rewrite things for you. And it's all running locally on a tiny NPU in the phone because they tailored it down to this really small model that runs very efficiently.
So that's really interesting because you talk. This is now moving into phones because almost every smartphone that you have now has NPUs in them. These are
And they have
neural
even before
processors.
LLMs. It's the
But
wild
even
thing.
before LMs, they had them, and they are specifically tailored to running neural networks, which all the LLMs are based off of neural networks. So that's really cool because I can have Chat GPT on my phone without it going out to the internet. That's pretty cool, especially if it could do like translation. And so we're moving in that direction, it sounds like.
I mean, it's already out for a lot of people, and I know Google's doing some stuff with their Tensor chips as well for their Pixel line. They've got something similar going with like Gemma, and I think they call it like Gemini Mini or something.
Well, and Qualcomm has that, and we know Qualcomm pretty much owns the cellular market.
Apple gets their modems from Qualcomm still, even though they're building their own chips.
So this is a really fascinating thing that we're starting to see. And just like with your glasses that you have on, which are smart glasses, wouldn't that be cool if it could translate? You're in Japan, you were in Japan recently. Wouldn't it be cool as if you're talking to someone, it automatically translated in your ear and vice versa? Hey, Star Trek is here, the universal
Well, and Meta
language
actually
translator.
demoed that, but it was running on the cloud. But I think, give it 5 years and we'll definitely have this in mainstream. People are buying this stuff, technology, if not less. The glasses are an interesting case because, like, they fit a battery into these. They only last a few hours, and it's not really doing a lot of AI stuff. But there are a few AI features in here. If the camera is covered by a hat, it will tell me that after I take a picture. It's using neural networks to do that locally on the glasses.
That's pretty cool. So we're already starting to do this stuff. It's just you can feel it. I can feel it sitting right there at the edge. All right, so let's talk about most people when they talk about private Gen AI, they're thinking I need a Linux server, I need to run it in the cloud. And I can tell you because I work at Intel, I've got 2 AI PCs now. I run private LLMs all day long on you're telling me that I can run them on Macs too.
Yeah. And this is where the Mac is a uniquely positioned product for this, honestly, by accident, because this was all engineered before the advent of LLMs. But they have the memory on die. So the RAM chips are on the CPU, which is also sharing the package with the GPU. So extremely fast memory bandwidth and totally shared between both CPU and GPU with the
That's very
capacity of
cool.
a full system of RAM.
So that's really cool because that's one of the biggest problems with these large models is the transfer of data between the CPU and the GPU because they don't have shared memory.
And on top of
But
that,
with
the
the Mac, they
capacity
do.
of memory available in GPUs that mere mortals can afford is severely limited.
Yeah, exactly. I like how you said mere mortals because you can drop 50 grand easily on a GPU nowadays, which is ridiculous. That's
And you can run
absolutely.
half a model with
And yeah, you can run half a model.
it. Here's 80 gigs. Like, that's a lot. Don't get me wrong. And when you start talking about cloud hosting, they are running unquantized models in a lot of cases. But what if you could get a machine that was capable of running those 80 billion parameter models, or even maybe even slightly larger ones? The standards kind of shift around for how large the models get for under 10 grand, like a full machine in one
That's
box.
nuts. Yeah, that's really good.
And
So,
that's where
and
the
there's
Macs are kind of unique because it's not about performance as much as the ability to run these models at all and the ease of having them in a single workstation.
right, and disconnected, because then I can run disconnected. I don't have to worry about data leakage. I don't have to worry about someone snooping in or even spoofing me. They're more secure. I can give it my own context. There's a lot of benefits to private.
And the
But
thing is that private context you can use because you have complete control over the domain of what's in the box and who has access to it. You can use very confidential information. A legal firm can have a private server and not have to worry. I mean, you can get enterprise packages from the big guys, but you have to trust them. And these big companies are also training models.
yeah, so they're looking at prompts. They
If
absolutely
nothing
are.
else, it's just too valuable to them. But if you go get a computer and you keep it offline or you keep it on the LAN or you have a VPN set up with a hosted solution, if you're a lawyer's office, you can keep all of these things completely isolated down to that one box and have very strict controls over who can access it. But what it means is when you're prompting, you can ask very specific details about the case and you could have all of the files available to it.
Oh, all right. So that's really cool, right? Because you don't want your lawyers going out there and asking on especially a high profile case, OpenAI, especially if you're suing OpenAI. You're not gonna go ask ChatGPT what's the best way to,
I imagine the New York Times is doing it all manually.
You mentioned a little bit, and here's your opportunity to pitch, Mac Stadium. You mentioned a hosted Mac. I didn't know you could do that. You're saying, well, I did know, but not until you started working where you're at. But our audience may not know that if they want to have instances of Macs running, they can actually go and provision one in the cloud.
Yeah. So, it's interesting. If you look back, so Max Stadium, just to give a little bit of background, we're a company that primarily and almost singularly focuses on Apple hosted hardware. And the majority of our customers, what they're doing this for is iOS CI/CD, right? Apple doesn't let you build on anything other than a Mac, but the Mac is also not really designed to be a hosted solution. They are all desktops at best, and the form factor is not really designed for something that you can easily put up in your data center. You have to deal with remote power management and all these other just odd things. So by being able to offer it as a hosted service, we guarantee it's going to be up, it's going to have fast internet, reliable power, despite the lack of redundant power supplies in the Mac itself. And from there, you can use these hosted Macs for whatever you want. It's just most of our customers are doing CI/CD. But with AI, suddenly the Mac Studio, especially if you look at these 128 gig RAM models, becomes a really interesting proposition, especially if you're looking at these companies or teams that might want to share a server that have very specific needs for confidentiality in their work. Suddenly, the cost is really not too prohibitive to go with a little more specialized hardware for this.
That's really interesting because I do have some customers in the government space they're using AWS to host their private Gen AI, but the number of GPUs that are available are really small. So they're paying exorbitant amounts of money. In fact, one customer, their bill was $45,000. Why? And they didn't use the box 24/7, but they held on to it 24/7 because the queue wait time was over 3 weeks. Meaning, if I need that instance, it took 3 weeks to get it. So instead, they just sat on it, and their bill just went through the roof. So what you're saying with this, I can host a private Gen AI at a major reduced cost, and because
And you
the
could keep
Mac,
it reserved that whole time.
yeah,
So a single H100 runs like 1,500 to 3,000 a month just for the GPU, and you still need other parts of the instance to make it a full solution, and you probably need more than one depending on what model you're running.
Yeah, yeah, exactly.
Whereas a Mac Studio, about $450.
So, wow, what an incredible, I mean, that's a new hosting option that I don't think a lot of customers are recognizing because like you said, they've got a GPU, they got a CPU, they have shared memory. It's a platform that most definitely should be looked at.
And in practice, it's not going to touch an H100 in performance, but like you said, how often are you really using this thing? If it's just periodic, like let's say you have a team of like 10 people. If it's just periodic queries against a reasonable sized database, or I mean, it's got 2 TB of local storage. You can load it up
No,
with
that's
documents if
pretty
you want.
big.
And that's included too, because it's on the machine. You're getting the whole machine. You're not paying. See, that's the other thing about cloud. Everything's itemized. You're paying 2,000 for the GPU. You're paying for every terabyte of stored storage and all traffic going to it. To get one machine for a group of 10 people that is fast enough to answer questions they might have starts to make sense, even though on the balance of it, it doesn't match the performance of the data center GPUs.
No, but you can scale it too. I need two, and I need two instances. That's only $900 a month because I've got 20 people. Oh, I need more.
You
Just
could set one machine up with the vector database and possibly even an instance of the embedding model. But what you can also do is you can chunk out OLAMA you can just run a load balancer in front of it. So
yeah.
scaling, it's really not that difficult.
Very, very cool stuff and great alternatives to what I think is a barrier to entry that is frankly artificially been imposed on us by NVIDIA because they'll be the first ones to tell you, no, you need an NVIDIA processor to do generative AI. And that's not true.
And not
And
only an
here's
NVIDIA processor,
another
but the
instance.
data center ones that come in fully integrated stacks that cost like $500,000 for the complete
Yeah,
solution.
for one server. Yeah, it's ridiculous. So Matthew, thank you for bringing some new light into and a new vector, someone else to compete with NVIDIA. I love it.
In a sense, yeah.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.